Good evening, class. My name is Ghebriela. I used to be a former student here about 2 years ago, and my teacher has told me to come and speak to you about mass and motion and the effect it has as it goes down an incline. So, our lab was started to answer a question about a group of friends. They went to a valley fair roller coaster when there were so many people during the day. So what they did was they were going on the rides and there were so many people and all that. So at the end of the day, they wanted to go for a couple more rides. So what they said was, oh, will it go as fast as it did during the day though? Because there's going to be less people, meaning less mass. So our lab was designed in order to answer their questions. So what we predicted was that since gravity pulls down mass, and the more mass there is, there will be more pulling. That was our prediction. So we say that it will go a little bit slower during the day. I'm sorry, at the end of the day than it was at the beginning of the day when there were many people. So before we get started, I kind of need you to remember this as you just went over it recently. Velocity equals to meters per second, acceleration is meters per second squared, and mass is measured in grams. Position, which is also same as distance, is measured in meters. And the only formula that I need you to remember is force equals to, or force equal, sorry, the only equation I need you to remember is acceleration equals to force divided by mass. Alright, let's look at background information of who did this kind of research before we talk about what my group did for the lab. So Galileo was one of people that was really interested in mathematics of motion. So during his house arrest in his lifetime, what he did was he tried to figure this out. And as you can see in the back here, um, he designed an incline where he would throw different sizes of balls and try to see if their mass affects the speed or anything. But the problem was he didn't have the technology that we have today. So he had to figure out a way how to make it slow down. So what he did was, as you can see, this little metal things were a way of making the ball to go slower. So he would measure it in kind of increments kind of thing. So he would throw the ball down where it would go a little bit slower, and he used a material, a pendulum thing that would, each time it was going, like he would calculate how many times he went back and forth. Like if we say this was a pendulum, it would go one like that, and once the ball stops, the pendulum stops, and he will calculate like how many times he went that way. So that was kind of measuring his time in order to see if he was speeding up or not. So he did that with different masses and all that. So he got results, but which we're gonna discuss at the end so that I don't give away what our finding was for our lab. Alright, so for our lab, the materials that we used was, as you can see in the diagram, we used motion detector, we used cards with tracks, different ways to be added to the card, and a computer with a Logger Pro program. As you guys have been told, Logger Pro program, you can manipulate it to measure anything that we want. One of them is position versus time graph, which the slope will give you the acceleration, and you can do acceleration versus time, velocity versus position, or position versus time graph, and you can manipulate it in any way that you are trying to figure out. But for our case, we're gonna do the uh, velocity versus time graph in order to find the acceleration, and then we're gonna plot the numbers, acceleration versus mass, in order to get our graph. So the procedure, what we did was we had the cards, as you can see, without weight added. We just weighed it first, which was 181 grams, and we let it go down the incline. And once it went down, we did it like 3 times. So we let it go down like 3 times, and we calculated the acceleration. For the second trial, what we did was we added 50 grams on each side, meaning it was 100 grams that was added. So we let it go down 3 times again. And then for the third trial, we added another 100 grams, 50 grams on each side, which should give a total of 200 grams, and we let it go down the slide 3 times. So we collected our measurements, and what we found are in this table here. You can see the mass of the card was 181 grams to begin with, then we added 100, then another 100. And in the trials, there were the acceleration that we measured for each trial. They're like in meters per second squared. As you can see, they're all here. So what we did was we had to average out the 3 trials. So we averaged for each mass, we averaged them out, as you can see in this table here. And also, as you just learned, we have to calculate the uncertainty to account for any errors that could have occurred within our measurements. So The uncertainty for the masses was 0.5 grams, and this was derived by the way that we used. It had uncertainty of like 0.5 grams. That's how we count. And then it, if you measure something, like it will go between back and forth between 0.5 grams. So that's why we decided that. And then for the acceleration, the uncertainty, what we did was we took the highest number of the trial minus the smallest number, then the result we got, we divided it by 2. So that gave us our uncertainty. And for each trial, like we did the same thing for each mass that was added, since they're different uncertainties. So based on this graph, based on that table, we were able to graph it. So the acceleration was in the y-axis, as you can see, and it was in meters per second squared, and the mass was in grams in the x-axis. So as you can see, if we ignore like the numbers for now, as you can see, it looks like it increased a little bit, but that actually is not true, because when we look at the numbers, the slope is 0.00022 plus or minus uncertainty of 0.00036. So in this case, the uncertainty is more than the slope. That means that the slope is negligible, meaning that if we were to add or subtract, like the slope can be even 0. That means that it didn't have any increase at all. So if we go back to the table as well, like let's look at trial 2. If we just look at trial 2, we can see that it increased. But this was without the uncertainty being added or subtracted. So if we were to add or subtract the uncertainty to this number, the numbers are going to overlap, meaning that nothing increased or decreased. So it's hard to tell. There might be a little bit of increase or decrease, but like it's very negligible according to our numbers. So the conclusion we came up with was that mass doesn't have any effect in the acceleration of speed, the acceleration of an object. And that's the same thing Galileo discovered, was that mass doesn't affect how fast an object goes down an incline. It will always have the same speed. And that concludes our topic today. Any questions? I can take them right now. Alright, thank you class, and here's my bibliography. Have a good day.